Hello class, welcome to week 7 where we discuss firewalls and network customization found in chapters 8 and 9 of the test out modules. Test out went over what a firewall is, the different types, how it can be used, and what it's used for, etc. The two main things you need to remember about firewalls are that there are software and hardware versions. A software version, a good example, would be, let's say, on your Windows machine, how it comes with its own built-in firewall. You can also install a software version of a firewall on, let's say, a server that is acting as the NAT. It's placed between your organization and the outside world. The hardware version is an actual device that you would purchase from a company, let's say Barracuda, where it goes into a rack and the connection from the outside world goes into it, and then connection from it goes into your core infrastructure to provide a NAT, a forward-facing IP address, as well as just a device. It's like a proxy server. We've talked before about what a NAT is. Oftentimes, companies will imply both software and hardware, such as that hardware firewall does have software on it. It has its own little operating system and so forth that can be used. But then a lot of times, companies will purchase both hardware and then they'll have a software version also. It gives them more flexibility, provides different layers of protection. So if the hardware version were to be breached, there's still the software version to go through. Of course, there are other security protocols that you would put into place to make it even harder for a hacker to get through. And really, just as a side note, as far as like network security, don't ever think that you will reach a level of network security where you'll never be hacked. It's not a matter of if, but when, as the saying goes. So what you want to do as a network administrator, especially if you get into the cybersecurity world, you want to provide layers of security that not only prevent various activities from happening at a lower level, such as a user gaining administrative privileges to install something on their computer when they shouldn't, kind of a basic example, all the way up to hackers from the outside world coming in trying to break into your organization's network. There are different layers of security, not only for that reason, but also if a hacker does begin to penetrate either from the inside out or the outside in, there are enough layers that they have to go through, enough doors, so to speak, that they have to break through, that there's going to be an alarm triggered somewhere, and it's going to give you, as the administrator, time to respond, hopefully, to the incident that's going on. Even as the attacker is trying to quickly, actively get through the system, if an alarm goes off, your job is to figure out what's going on and then respond appropriately and begin to isolate and shut down that individual. Sometimes it is a matter of just unplugging a device. For instance, many years ago, before an organization implemented the security procedure of locking down all computers. So you had two organizations, sister organizations. One organization thought it was ridiculous to restrict users from installing anything on their computers. They just let their users pretty much do what they wanted to. After all, there was freedom in doing so. And then the other organization restricted users to a basic user profile, so it would require an administrator to install something on a company computer. Because of their limited account, it prevented an incident from happening. So sister organization, somebody downloaded something and created a bot network. It began to spread rapidly throughout their organization because everybody's computer, everybody's profile was an administrator, and it spread that much faster. It jumped over because the two companies were connected. It did jump over to one person's computer in that organization and began to slowly spread. Set off alarms. This company was going crazy because their network was down and they were heavily infected. This company saw what was going on here. They saw alerts that were starting to happen here. They were able to trace the issue back to one computer and basically unplug that computer from the network to isolate it. The spread stopped. and this company was protected from the attacker, whereas this company was not protected, and they had to deal with the fallout afterwards. So that's just kind of a basic idea of how layers of security help you as the network admin and systems admin to protect your network and your systems. So again, a firewall is a device or a service that allows the administrators to filter traffic, to watch network traffic going in and out of their organization, and even filter, or I should say even monitor what's going on within the organization, working hand in hand with the antivirus program. The firewall is primarily, though, concerned with the connection to the outside world, both inbound and outbound. There are multi-service systems, which we talked about, how, let's say, a hardware device can have the software on it and provide those different levels of security, or you can purchase software and the hardware and combine the two systems. Some might think that, well, why would I need that because I have a Windows firewall? Again, it's layers of security. That Windows firewall provides you on that device, or I should say just provides that one device with some protection. It's not unlimited protection, it's just some protection. So layers of security is what you're going after. And then because a firewall that's been set up between your organization and the outside world, all ports that are not being used are going to be shut down. And there are companies that will require certain ports to be opened, at least to their traffic. And so if you're not the administrator to the firewall, but you are supposed to set up a particular service or software within your organization that does require connection to the outside world, you definitely want to include your cyber team, which is usually going to involve firewall, and also your WAN engineer, if you have one, just being aware of those individuals, unless you yourself are those individuals as well. But just be aware of, if your organization is large enough, be aware of the individuals that manage those things. You can't fly solo in some of these situations. So depending on the size of the organization and your responsibilities within that organization, you may have to include outside teams. So just be aware of those facts. A SAN and NAS storage. So a SAN is storage area network, and your NAS is a network attached storage anything. They sound kind of similar. They both are connected to the network. They're both accessible from the network. They both provide storage. They actually both require a server. So you're thinking, okay, what's the difference? Why do I need to know the difference? Well, you need to know the difference not only for the test, but also when you get into a business environment, to know either what's there already or what should be there. A NAS is definitely going to be cheaper than a SAN, but a SAN is able to do more than a NAS. So a NAS is basically, picture a specialized server. If you've ever seen a pancake server that has an array of hard drives, that's basically what it's going to look like. It's set up specifically for data storage, and it's of course connected to the network. It's cheaper and easier oftentimes to set up, but it provides one point of failure. So oftentimes you have to have two of those things in place, where one is the exact duplicate of the other, so that way if one fails, it can revert over to the duplicate. That's not always cost effective. And then if your organization begins to expand beyond the size of that NAS, scalability is definitely something to take into consideration. Whereas a SAN is definitely easier to, it's elastic. You can get bigger or smaller as you need, because how it's set up is you basically have a thin pancake server that goes into the rack, and it is connected to a controller, and that controller is connected to an array of hard drives. And that array, it's basically just a giant box with a whole bunch of bays, a few rows of hard drive bays. You don't have to fill them all up. You can only do a few if you want to. whatever the minimum is for the particular rate that's being set up. So it is scalable. In one sense, it can be cheaper because, you know, if you need more space, you go get more hard drives. Rather than with the NAS, you know, having to purchase another NAS system. A SAN can also be faster in some ways. It's also more reliable in that if something begins to go wrong with it, you have failover options. There are a couple of controllers, there are a couple of servers that are controlling everything. And NAS also has in a RAID, you know, if a hard drive goes bad, you pop one out, you put another one in. But with a SAN, that's definitely the case. It's set up to where you can do a hot swap. So there are pros and cons. Again, the SAN is oftentimes, it has a bigger price tag initially. And it does have high-speed connections, or a SAN does require a high-speed connection, whereas a NAS does not, but the benefit is you have a high-speed connection. So if your business requires access to a lot of data, you know, fairly large organization, everybody's saving to a centralized location, a SAN is definitely something to shoot for. So it's something to keep in mind if you become a network admin, or if you are a network admin and you're faced with having to provide network storage. VoIP. So VoIP is voice over IP. Uses UDP as a side note, which, as we've learned before, the UDP is the IP protocol that does not require checking on the packets. If you remember TCP, it checks to make sure that the packets are arriving in the proper order and that they're being reassembled in the proper order. UDP doesn't care, it just shotgun blasts those packets out, and whatever the receiver gets, the receiver gets. And that's how voice over IP is transmitted. It's not super critical. If some of the packets are lost and you hear a little bit of distortion over the line, you know, or somebody kind of garbles out for a second, and you just ask them to repeat what they said. All right, compared to the old analog phone line, the old analog phone line basically needed, if your company was large enough, they would have their own PBX, which is you know, where all the connections would go to. You have your 66 blocks, etc. And you would have a connection to a phone provider that would come in and, you know, they would go through the info and actually provide you that connection. It was fairly straightforward. It was pretty easy for the most part to set up and, you know, maintain. I mean, there were a lot of things that you had to do, but it wasn't super bad. The VoIP system made things easier and more complicated all at the same time, because VoIP, you require more equipment, more network knowledge, but thankfully not as much hands-on work as the old phone lines used to. The old phone lines, I mean, you definitely had to do a lot of manual hands-on labor of finding the lines and punching them down, etc. And of course going into your PBX box and doing stuff. So with VoIP, the equipment you'll need are, of course, a network. You'll need IP addresses set aside in a subnet to create a VLAN for your VoIP system. Of course, you'll need cables to connect the system together. Most VoIP providers require specialized VoIP phones, and of course a VoIP server, or servers as the case may be, and possibly VoIP gateways, which means that if you've got a centralized office where the VoIP server is located, you can have gateways at the remote sites, and they basically act as kind of a temporary server in one sense. It's basically a switch or a router that takes the traffic and points it to the server. And then, of course, possible VoIP software on the computers, as well as the server. So that's quite a bit of equipment and can be quite costly up front. There are pros and cons to VoIP system. Pro is that it's modern. It comes with a lot of cool features. You can do a lot of really neat stuff that you couldn't do with the old POTS phone line. You also have software that can be used with the VoIP system. It all runs over the network. Like I said, it's definitely less hands-on in one sense. And if you want to configure stuff, it's fairly easy to configure because you're doing it all from either the server side or the software side in some way. You don't actually have to go out there and find lines and move lines around, figure out how to, okay, this person moved from this building over to this building, and we've got to jumper multiple 66 blocks in order to get them their extension over at this building. With a VoIP system, it's just using software saying, yeah, this person, oftentimes you don't even have to do anything. If somebody is moving their desk, they just take their phone with them and they plug into the network and away they go. It really doesn't care where they're located as long as that network has that VLAN. Even if they move, let's say, to a different campus, let's say you're at an educational institution to go to your semester assignment, and a person is traveling from campus A to campus B and then to campus B to campus C, with a VoIP system, they don't have to worry about having multiple extensions like you used to. I used to travel to different campuses, and I would have to have an extension at each campus in order to, unless I want to be calling voicemail constantly, in order to get my phone calls. I'd say, okay, I'm going to be at this campus on this day, and here's my campus number. With a VoIP system, it didn't matter. I just have the same extension, and I moved around to all the different campuses. So in your semester example, let's say the person going from campus A to campus B to campus C, doesn't really matter. Their extension follows them no matter where they go. They don't even have to take their phone with them because they can actually go to the VoIP phone and log in with their extension, and that's where they're at for the day. So VoIP systems definitely have way more benefits than the old POTS line did. Including alert systems, to where, if there's an emergency, all of the VoIP phones can be turned into speaker phones and can send out alerts regarding certain situations. So there's definitely some major benefits to a VoIP system. The downside is they do require the network. So if you're having network issues, sometimes that means that the phones either may not function properly or that they don't work at all. So a lot of times the VoIP system will work internally, but let's say not be able to make phone calls outside of the organization or phone calls in. There are myriads of things that can go on with a VoIP system. So that is kind of the downside, of course, the cost and the knowledge that is required to set up the system and then maintain it. Oftentimes it can be kind of a learning curve to do so. So some things to consider. Terms that were used, PBX, which is a private branch exchange. That's the old-time term for the business managed phone system. There would actually be a room set aside with a PBX box. The provider would, come through the wall, patch into that, and then it would come out of there and go into your 66 blocks that were all over the wall and would go to various locations. And the 66 block lines would run to buildings, to different floors, etc. So the PSTN, or the public switched telephone network, is basically just the telephone system, telephone landline system. The POTS, plain old telephone system. The hard phone versus soft phone in a VoIP world means that your hard phone is the actual phone in front of you with a handheld receiver. And the soft phone is a software version that's on your computer. You can actually set it up via the software to plug in a headset, earbuds, whatever, even a specialized headset, plug it into your computer, and through the software say, okay, my computer is now going to act as my desk phone, and I can answer calls and talk on the phone with my headset, my computer microphone, and speakers. Because the analog world still exists in a lot of places, especially for faxes, that is a technology that surprises me that it's still around, to be honest. So, printers, multifunction printers, MFPs, will still have a fax connection in them, and oftentimes use the network admin are called to, somehow figure out how to keep the fax line going, even though your company has eliminated the landline. And so one way to do that is through an adapter, a converter box, also known as an ATA device, that allows the digital Ethernet connection to be plugged in. That's connected to your VoIP VLAN or whatever and a analog phone line plugs into the other side and then goes into your fax line. And however you have that set up with your VLANs. And that information is converted, that little box is able to convert those signals over, and so people can send and receive faxes actually using your network. It's kind of problematic at times, just because adapters a lot of times fail. We've had ATA devices that we have to reboot frequently, all of a sudden the fax stops working. It is kind of humorous to get a call and say, yeah, I haven't had a fax in a long time. It's like, well, is anybody sending you faxes anymore? But so we go up and we make sure it's functioning, and then sometimes we do have to reboot the ATA device in order to send and receive faxes. So let's see, SIP, you heard that term, Session Initiated Protocol. It's often used as a VoIP protocol, so it's a open source. So you have a SIP device, a SIP trunk, that allows the VoIP traffic to be forwarded to, let's say, the server, transmitted across your network, basically. Virtualization. Some of you have experience with virtualization. Some of you have experienced virtualization through the assignments. In a nutshell, virtualization is taking a device's hardware and installing a program on the computer that then allows for a computer to be built inside it using that host's hardware. Looking at it, if you downloaded VirtualBox or if you use Microsoft's Hyper-V, you can create virtual machines on your computer if it's able to handle it. Unfortunately, virtual machines, or VMs, require somewhat robust machines to run them a lot of times, because again, you're sharing those resources. If your computer is pretty much maxed out, hard drive space, RAM, and CPU, then you're probably not going to be able to run a VM. So it's best to have a device that definitely has some good hardware to it, and can handle that type of traffic, that type of activity on its system. So virtual machines share hardware resources with the host computer server in order to create a virtual computer or servers. So you've heard people mention ESX, which is a host system that basically takes a server. Oftentimes I've seen it used in a SAN type environment, to where you have a server that's an ESX host, and it's built to where you have your CPU, your RAM, and then your hard drive, all in different arrays. So that way you can actually add or remove as needed, and to create large server farms. That's a more expensive way to do it. I've also seen it done on a regular pancake server that actually has a fairly good amount of resources available. It's dedicated to being an ESX host, or just a host if you're doing, let's say, Hyper-V or whatever. ESX it's VMware's host platform. ESX is a host platform of its own. So, but if you're setting up, let's say, Microsoft Hyper-V, you can use a regular server for that and set up your own server farm or your own VM farm, as the case may be. So the difference is full virtualization utilizes all the hardware allocated to a VM, and it emulates a real physical computer. And again, the key is it utilizes all of the allocated hardware to that VM. Partial virtualization, parts of the VM use virtual devices and then actual hardware. So in some cases you have, and this is actually fairly common, to where you actually have, let's say, a CD drive attached to your VM, which in reality is just an ISO file or an ISO that gets created. That's kind of a good example of using virtual devices. Then you have parallel virtualization, whereas the VM thinks, the VM's operating system thinks it's the actual operating system on that device, and so accesses the hardware and of the machine when it needs to, just like Windows does. There's nothing allocated to it. It thinks it's the main operating system, so it's going to utilize the hardware as it needs it. Again, you need a robust system for some of this stuff. So, if you're running a VM on your operating system, and you're trying to do stuff on your operating system and on the VM at the same time, and they're both trying to access hardware at the same time, you could, max out your hardware. A place you might see this is if you've set up a server and you've done a data center installation of a server OS without the GUI interface. And so the server OS is running bare bones. It does not need to be used for doing anything other than running the host systems. That way the other operating systems, if they're doing para-virtualization, can access those resources without interrupting the other operating system, etc. So there are pros and cons to all of those, and you kind of have to weigh the not only the cost, but also what your machines can do. So network virtualization. Now we talked about VLANs. VLAN is a type of network virtualization, and they kind of touched on that in the videos. So that's what it stands for, Virtualized Local Area Network. That's what a VLAN is. So basically it's taking an actual network connection and saying, I'm going to divide this into multiple networks basically. It's one Ethernet cable, let's say, that's being run, but we're going to virtualize the network to where it's like I've run 10 Ethernet cables. So that's what a VLAN would be. Each of those cables would represent a different network, different local area network, so to speak, which allows you to, of course, segment your network. You can, regulate who has access to what, etc. So that is an example of network virtualization. But also in the VM world, a network virtualization, you can actually set up a virtualized network. Now you kind of had a little bit of exposure, some of you, to a network emulator that kind of gives you an idea of what it might look like, but you can actually go further than that to where it's not just emulating anymore, it's an actual virtual network to where these VMs on these hosts are connected to virtual switches. So the server, the host, can actually be set up to use one or two Ethernet connections that it has in the back, or even a fiber connection, and have a switch inside that it then splits up into different virtual local area networks, or VLANs, allowing you to have, let's say, a print server on the printer VLAN, a data server on the data VLAN, etc., etc., etc. And so that's an example of the virtualized network, and you can go even further to having virtualized firewalls and so forth. So the virtual world has become kind of fascinating to where it's expanded into what we would normally think as restricted to physical. And of course you can implement virtual network devices, like I said, switches, routers, firewalls, etc. Cloud computing, the wave of the future. Everybody's on the cloud now. And there are a lot of pros and cons to the cloud. If you get your cloud certification, you get to learn all about it. And invariably, if you work for a company, you might run into one of the CFOs or whatever that they stumble across this concept of cloud and all of the benefits of it. They attend a seminar and they come back all pumped. They're like, yeah, we're moving everything to the cloud. And so use the network admin or systems admin, or both, get to figure out how that's going to be done and the pros and cons of doing so. Because not everything should be in the cloud, and there are, again, pros and cons to the cloud. Not only cost-wise, you have to weigh the cost, because a lot of people go, well, it's cheaper. Not always cheaper. Sometimes it is more cost-effective to have it on site, depending on what that service might be. But there are benefits to being in the cloud, because you can access data, cloud-based data, from anywhere, because it's on the network or it's on the internet. So But then that raises some security questions. Well, if I can access it, does that mean that anybody can access it? And their response is, well, of course not. It's very secure. Well, as we talked, nothing is super secure. So you have to decide, okay, if their system were to ever be hacked, or if their morals were to dip a little bit with the data that I store on their servers, them and they're being, let's say, Amazon or Microsoft or Google or whoever the host might be, if their policies take a dip for some reason, is my data going to be affected? If we're storing sensitive information, you should really never store sensitive information on the cloud, but let's say you do, is that a concern? So that is one area of concern that you need to think about with the cloud. Again, the cost, kind of weigh the pros and the cons. A lot of the cost pros come in maintenance. You don't have to maintain servers. You don't have to maintain network infrastructure, etc. The cloud service provides that for you, but at a cost. So sometimes you have to weigh that out. Man hours, downtime, etc. So the cloud equals virtual services run in a company's server farm. Company being, again, Google, Amazon, etc. And they have a warehouse of servers, SANs and so forth, that provide clients with storage or services of some sort. So some of the services are known as SaaS. SaaS is software as a service, or SaaS, I should say. NAAS is network as a service. IaaS is infrastructure as a service, and PaaS is platform as a service. And those are phrases you will need to know possibly for the test, especially if you take the updated version of the Network Plus exam. So software as a service, what does that look like? That means that you don't have to provide the servers or the network infrastructure in order to run a software service. And this can even extend to the point of having software available to where you don't need a computer on site, let's say. So a good example is a college institution it provides an SaaS service to its students in the form of a cloud-based VM, if you will, that provides software icons on a web page that they can click on and access that software. So let's say Microsoft Office 365. They can go to it, click on it, and it goes to that software. Microsoft Office 365 is a good example of software as a service, to where you go to the office.com, you log into it, and you have access to their software that's in their cloud. It's not installed on your computer, it's all through your web browser. So that's software as a service. Network as a service. You're going to actually have a virtualized network, basically. You don't have to have any infrastructure. All you need is an internet connection, and you can set up VPNs, VLANs, etc., all within this cloud type system. So even your network can be virtualized. Infrastructure as a service is where you have actual, let's say, a server infrastructure that you have to install your operating system on and so forth. And then they basically give you the server in one sense. It's a virtual server, but they give you the virtual server to basically do whatever you want. It's not software as a service. Software as a service is they're just providing you the software. If you need access to Word, etc., that's what you get. Whereas infrastructure as a service is where you've got the server, you can install whatever operating system on that you want, any software, etc. Whereas a platform as a service, PaaS, is where that one's kind of a general term, but it is more of the, okay, now you've got an operating system, so I really put this in the wrong order. You have software as a service, kind of platform as a service, infrastructure as a service, and then let's say networking as a service. And then of course you have the XaaS, which is just everything else as a service. So you will need to remember those terms. Of course, your cloud-based services make offsite work much easier, and you can also use cloud-based services to quickly set up a business. They don't need heavy infrastructure on site. They don't always need a network admin. An executive can go to a cloud provider and just purchase the services needed, and they just walk them through and provide everything that is needed. It provides, sometimes more cheaply than a business hiring IT personnel to come in and set up a full infrastructure and maintain that. So the cloud can definitely be more cost effective in that way. There's also the full assurances of accessibility, availability, and reliability. So it's accessible from anywhere, it's available at any time, and it's reliable in that, whereas your local infrastructure, power goes down, network connection is cut, whatever, you're toast. Whereas the cloud, people could essentially work from home and still get the job done. So it provides oftentimes better service than an on-site business might. And then, of course, cloud services are elastic. That means that they can expand or contract as needed, especially if they're set up that way to where they only use the resources that are being used. And you only pay for the resources that are being used. So if your business, during certain seasons expands, you pay for those resources then, and then off season it contracts and you only pay for those resources. You have to pay attention to plans though, because there are some that block off. Okay, I'm going to use this many resources, and you pay for it regardless. And then if you have to go beyond that, you pay extra fees in expanding. Whereas if you go below that, well, you're still paying for this over here. So if you pay for their elastic service, again, you have to weigh the pros and the cons and the costs. Their elastic service allows the business to expand and contract services as needed. All right, that is the end of week 7 and the topics of chapters 8 and 9. If you have any questions, please let me know.